Simulation of chemical equilibrium. So before we get into the equilibrium section, I have this interactivity for you to do. It's kind of a neat thing. It really explains a lot about chemical equilibrium, and it provides a real-life analogy for you that hopefully will make the whole equilibrium section make sense. So purpose to illustrate what will happen when reversible reactions are placed in the system. Then later on, you'll call me to come around. I'll do some things, and then we'll look at the effects of a stress that has been placed on an equilibrium, what exactly happens there. So the materials are really, really easy. Two 25 mil grad cylinders, like that. Two drinking straws of different diameter, so you know they have different diameter if you can fit one inside the other. It's very important that we use both of those. And of course, water. So drinking straws will be used to transfer water from one grad cylinder to another. Transferring water from one cylinder to another will be simulated to be the forward reaction. And the other straw taking water from another cylinder will be the reverse reaction. So you'll have a setup very similar to this here. You'll have two cylinders like that. We'll call one A, call one B. See how it looks pretty good there? And the cylinders. So taking water from this cylinder, putting in this cylinder is the forward reaction. Taking water from this cylinder, placing it back is the reverse reaction. Okay? So let's move those off to the side for a little bit. So forward and reverse reactions, and that's what we're going to try to simulate using water and cylinders. So the procedure, label the two cylinders A and B, place a straw of different diameter into each of the cylinders, so it doesn't matter which one I use. Put one of the straws in one, the other straw in the other one. Place 15 mils of water into grad cylinder A. So take the straw out, make sure it's up to 15. So once again, be sure to read the bottom of the meniscus, and you'll be able to go to the nearest 0.1 milliliter. So all your measurements should be like 15.0, 15.1, etc. So make sure you go one decimal place. So 15 mils, put the straw in. And create a table to record what's going to be happening here. So my table got a little wacky here. Yours looks better. So of course we're starting off with 15 mils in grad cylinder A, 0 mils in grad cylinder B. And once again, you're going to be doing the measurements after you transferred the water and before we put the straws back in. Okay, that's crucial. Don't do the measurements with the straws and the cylinders. So place this. Now we'll do the old thing like you did in a fast food joint when you're a kid. You put the straw in the liquid, index finger or thumb, and you know that we're preventing the air pressure from pushing that water out, and we're basically hanging on to it. So what you're going to be doing here is, well, I kind of got long-winded here to describe how to do it. So basically, at the start, catch that water. Of course, I know here we have nothing, but we'll just pretend we have something. So move it over, drop it in. I just let go of the top here. You didn't see it, it's out of the camera view. And then I'm going to be putting the straws back where they originally are, but before I do that, I take the measurements. So this will likely be less than 15, and this will be larger than 0. So then you write that on the table. That'll be trial number 1. Then put the straws originally where they are. Don't switch the straws around. And do the same thing. So take it in, go over, drop it in. We're going to put the straws back where they originally are, but once again take the second measurement and you'll have trial 2. And you just keep doing that, etc., etc., as it says there, until you see that the volumes are constant. When they're constant, call me over and I will give you further instructions as to what to do. So that's number 8 there. So by showing you what to do there, it took me a few sentences. So just hopefully this video reinforces what you're supposed to do. After you're done this lab, there's a graph to plot. You're going to plot the volume of A versus trial number and the volume of B versus trial number on the same graphs. You'll have two different curves. And then there's some follow-up questions there. Some of the follow-up questions we're going to save until later, though, when we do Le Chatelier's principle and look at the second part of equilibrium, because this simulation basically ties in the entire equilibrium unit. And it's a really good analogy to illustrate that whole thing. So there you have it, analogy of equilibrium.